Okay, welcome to this second session. The goal for this session is to analyze an image stack instead of a single image. So what we're going to have is a set of experimental images that are in one folder, and they're all named in sequence in some way. And what we're going to do is do a very simple region of interest analysis through all of the files that are in a particular folder. So here's an example that I made of exactly what you're going to do in this session. So let's just find the VI. I'm sure I opened it recently. ROI image stack. That one will work. Okay, so what we have quickly, front panel, image pane, something to read out these intensity values across the frame number, file path, a little progress bar. There's also a little array setting down here so that if we want to, we can read independent values out for particular frames. So the first thing that we need to do is we need to say where the image folders are. In this example, we'll use Celine's images, and it doesn't matter which image we choose from within a folder. It reads the folder path. It reads the folder path, so we can choose any image. It does not matter. The only thing that matters is you choose the image which best shows the region that you want to look at. So we're going to use this one. Once we've chosen that and quickly looking, okay, it's in the right folder, we just run the VI, and here's this image. And then we get to choose where in this image we want to look. And we're actually going to look kind of down here. It's not much down in this region. And we want to see if this interface kind of spreads over a little bit. So we have our box. Then what we do is we just hit run. We have the progress bar telling us that it's chunking through. This example, I think, has approximately 350 frames in it, so 350 files it's going through and analyzing. And once it's done, it'll display the results over on this little graph. Like that. What it's saying is that there was average and not much intensity during that region, then something entered that region that was quite bright, that went away, something else came back, and slowly drifted out of the region. So there might have been some motion at that point. And that's it. We have a very simple input image path, choose region, hit run. I will show you in later sessions how to get this data out of it. Probably the third or fourth session I'll cover how to output data. And just quickly do the scary thing of looking at the block diagram. It's fairly small, and quickly we have our image path. And down here it gets read into a file reader. So we make space in the memory, we then read this file into an image, and then we show it. And then this is a while loop, so it runs around this while loop and just keeps showing this image. And what we're actually doing, just like it says here, is we're creating a time delay so that we have time to play around with the region of interest, move it where we want to. And then when we've set it where we want to, we hit the run button, or here it's called stop, but on the front panel it's called run. Then once we hit that, we read out the region of interest that we chose. And then, just like the first example, we convert from one type of rectangle to another type of rectangle. And then we send that to this handy little light bulb, please read the intensity VI. But what we're interested in is not one single image, but instead a whole set of images. So this image path, which was chosen for one image, the path then gets stripped off. So this strips the path off. If we had a little indicator here, it would tell us what this file was, but we just want the path. Then there's another inbuilt VI which will create a list of all of the paths for all of the files that are within this folder. It's very high level, I would say. doesn't really care what's in the folder, it just lists everything. And you can find out exactly what's in there. You can exclude certain subfolders. You can tell it to look for a particular pattern. So if you have, as in some examples, there are file names that have something which indicates which channel it's taken from, we can apply a little channel and say, look, we only want to look at channel 1. So then it will only tell us which file names have the name channel 1 in it. But we produce this list of names, and then this for loop does the indexing of it for us. So this is a big array of file names. As we run it into here, Labview knows that we want to do this individually, so it indexes each one of these, so we run them one at once. So each time this loop executes, it gets the next one from the list. We have a very simple progress bar maker that shows us what the loop number essentially is that it's running on. And here what we do is we have this list of files, we index it, so we choose the next one in the list. That gets written to this space in the memory, so it becomes an image. Then this VI, using the region of interest that we chose, tells us what the intensity is within that region, and other information too, but we're using the intensity, the mean intensity. We then output that to the same kind of indexing that we had for input. So here, where it separates them into individual components, on the output, we're actually putting them into an indexed array, so we're stacking them up one on top of each other. So it does it itself, it's just an indexing function as part of these loops, so that when we display this, they have their own numbers associated with them. So on the first loop round, the index is 0. So if we look at the front panel, on 0, which is the first time it runs round, this is what the intensity value was. On the second run round, which is index 1, this is what it is. And for each time it goes round, you get a new index number and it read out a different value. And that's all this is doing too. This is a simple graphing program that takes the index number and the number that you assign to it and makes a very simple line graph. And that's all this program does. It's a quick little program to show you how to analyze a stack of images instead of a single image, which introduces this use of for loops and indexing functions, both input and output. Okay, thank you.